Good morning, I am Xuan Pham. Today I intend to present robot car control by using IoT technologies. Yeah. Let's start from the first slide. Okay, introductions. Uh, what is IoT in robotics? At the Internet of Things, we enable devices to connect, communicate, and make decisions based on data. In robotics, IoT allow real-time data exchange, remote control, and automation. Robot car is uses for various applications like delivery system, self-driving cars, or smart logistics. The objective of my presentation today is to explain how IoT enhance robotic vehicles and discuss architectures, operation procedure, tool for development, challenge, and future improvement for robot car. Overview robot cars. Um, yeah, the self-driving robot car is use IoT technology or for remote control, navigation, and control system. Main features of robot cars is including obstacle detection, GPS navigation, remote control via smartphones or website. PID control for motor speed regulations and real-world applications for smart transportation or automatic delivery system, securities, surveillance robots, or either pictures of robots. In front of robots, we have the obstacle protections like for safeties, and the indicator lights for indicates the robot is on, off, or any failure. And GPS is installed on this robot. We have overview of hardware of robot. The first one is the devices for using for robot like GPS, voltage sensor, current sensor, or encoder for speed detection, motor, batteries, ultralightic sensor for distance for safety, and as well as like we also have like communication devices, but it's another side. And secondly, the main system controllers is Raspberry Pis and ESP32s. But Raspberry Pi plays roles for like a web server or MQTT broker only. But ESP32 is communicate directly to devices and communicated to equipment to control card. And communications, third one, and finally it's HMIs for human-machine interface. So people can activate from an human interface and control using communications and controls the ESP to control the robot. Core technologies, we say that MQTTs using over Wi-Fi, LoRa, and remote control PS2. And microcontroller is including Raspberry Pi and ESP32s, motor drivers, sensors, and power source, lithium batteries. System architectures and block diagrams. The robot car including 10 batteries for control motors and 3 batteries used for control system. Supply power for Raspberry Pi and other devices. Each battery has 12 volt and 7 ampere power per hour. Motor driver is get a voltage directly from motor batteries. That is including 10 battery totally 70 ampere per hour. And the 3D system architecture block diagrams, we see that the 10 batteries for motor here with voltage sensor, 3 batteries for control site. ESP32 and Raspberry Pi play a center control unit, and another human interface used for control remotely by Wi-Fi, MQTT, and WebSocket. Motor controller. Now we discuss about communication flow. Communication flow in local area network. Raspberry Pis play a web server and local MQTT brokers. And ESP32 is the center control unit to control cars. Devices like motor, sensor, anything from robot. ESP32 have a web server inside. MQTT client, web socket server, web server, and main controller for robot car. And communication flow, ESP2 remote is controls car directly to ESP without like Wi-Fi connection or MQTT connections. It's controlled directly. And web server from ESP32 is accessed by HTTP port 80 and directly control cars by web server from ESP32. Another thing, MQTT brokers in Raspberry Pis. So data from Raspberry Pi from ESP32 will transfer to brokers, and another devices like MQTT client can access broker to send and receive data. So that ESP32 also communicate with brokers and public and supply data, so that it can control RobotCar following the command from the client. So let me explain. MQTT's client from here is send data to MQTT brokers. ESP32 supply the topics and receive data from brokers and control car. And ESP32 public data to brokers. Client supply the topics and receive data from ESP32. Like this. Okay. In local area network, we can use the MQTT client from Python, from Android application, or from web server. This web server is from Raspberry Pis. When the computer access the web server from Raspberry Pis, on the web page data will send to computers. The communication protocol is MQTTs. We send and receive data to broker, and so that ESP32 can receive data and control the car. We finished this slide. Internet network data control flow. In the internet network data flows, Raspberry Pi is not used. All the data from ESP32 will publish to MQTT brokers, and ESP32 also supply the topics from brokers. So all data from ESP32 can send directly to brokers. Any other device in the in the internet environments can publish and supply the data to brokers, and so that it can receive data from ESP32 and transfer data to ESP32 to control robot, like from Python MQTTs or Android application MQTTs. It will send data. So Raspberry Pi is now not used anymore because the web page is now located in web host. For another web client can access on the internet, we can access with domain name waikato.robotcar.greatsite.net or robotcar waikato.greatsite.net. So when the computer access the website from web host, on data from web host on internet will transfer to the computers. And the web page with the communication protocol like MQTT communications, it will public and send and subscribe data to MQTT broker on internet, so that data from ESP32 can be monitored in any computer on over the internet. And the equipment, the controller from here can control ESP32 through MQTT protocol. So ESP32 will be controlled over internet by MQTT protocol. So the same with Python or Android applications. With MQTT protocol inside, it connect directly to brokers and control ESP32. So MQTT can connect various equipment. And software implementation for robot cars. We use Arduino IDE to program for ESP32. In Arduino IDE, we separate each function at each pace so that we can troubleshoot easily. Secondly, we use Visual Code HTML for programming HTML, JavaScript for web page for ESP32 and web page for to internet, the computers. Thus, we use Python with PEQT6 to program interface for robot car. And finally, we use MIT application for programming Android application for robot cars. Safety protection. Safety protection is one of the most critical parts of the robot car designs. So to prevent any accident happen during using robot, we install some safety device like RobotCar on installed with current sensor monitoring to stop motor whenever current exceeds the motor ratings after 30 seconds. Motor fuses are also installed to prevent overcurrent. Secondly, voltage sensor also installed to stop motor whenever voltage drop down than limit setting about 70% voltage rating, so to prevent battery overcharge. Up and forward of the car installed with ultrasonic sensor distance sensor to stop car in the setting safety distance. AP LiDAR detect the range forward and up distance from car to objects. If the distance is lower than distance setting, the car will stop. I will show it later. And by image processing, Intel Ryzen camera D455 can set if any people, any other objects in front of the car lower than setting safety distance, the car will stop. Let's see from here. A stop car by distance sensor, voltage, motor after 30 seconds. So in the program, we already write safety protection for like voltage and current, and safety distance ultralightic sensors. And we also set enable aft sensor and forward sensor ultralightic sensors for stop cars. Safety device AP LiDAR to detect forward and aft if any object obstruct the cars with a safety distance setting, so it will stop car immediately to prevent accident. In front of and aft car already installed ultralitic sensor for detect any object in the safety range. It will stop the cars. Now we wrote some videos method of controlling robot cars. The first one, we control robot car by remote PS2. Remote PS2 is designed to control the car directly. If any error from the network, like communication protocol, like no network, no Wi-Fi, or no routers, the remote controller will control car directly to operate the car directly from remote PS2. Okay, let's go a short video to control robot car over remote PS2. Okay, in front of you that is remote PS2 and the receiver is here.
Here we can operate this.
When we press the buttons to enable robot, the indicator lights will receive on the Python program.
See indicator light.
The Python program is only monitoring the car operations. It's not related to PS2 remote. PS2 remote working independently.
You can start it forward.
You can change speed, moving left, right, or turning over by remote PS2. Change speed.
Increase speed.
Data from motor can be monitored from website or from Python program. Okay, now we finished the control robot car by remote PS2. We let's go to another sections. The video control robot car over web server directly on PS2 ESP32. This is the robot car. We will try to operate the robot car website. Yeah, in front of the robot car we have the safety devices and indicator light. Now this is web server for directly on ESP32s. Data will send and receive to web page. Enable robot car start, and now we can change the speed and start robot. Now robot car moving. Normally, ES2 already programmed DNS server, so we don't need to remember the IP address. Okay, let's go another sections. Now we control robot car by web server on Raspberry Pis. Let's say ESP32 Raspberry Pi is installed in the RobotCar for place a layer web server with MQTT connection and WebSocket communication, MQTT and WebSocket communications. So we go to open the website on Raspberry Pis.
Control RobotCar over web server on Raspberry Pis. Raspberry Pis here. So what we do, MQTT, we need to type.
Now we set up the IP address for MQTT brokers.
The broker is on Raspberry Pi.
I already set the static IP address for Raspberry
This
Pi.
one is
So in this
talking about
video, I haven't set it
WebSocket.
yet, but
So
the updates
what
one
we
is
do,
I already set permanent IP address
WebSocket
and
first.
domain name for Raspberry Pi, so we don't need to remember IP address.
Address of Raspberry Pi. So what we do, typing.
See, we open website on the
IP address of
Raspberry Pi and
IP address
connect
of
WebSocket, and data will send to web server,
RobotCar from here.
and we can control robot
That's
directly from
the first time
website.
we need to change the speed. Forward. Let me check because the robot is now. Disconnect charges. Okay. Now we are doing control.
Okay, let's go another sections.
Web server on
Control car by web server on internet with MQTT protocol. So on internet, we need to connect your Wi-Fi to internet and open web browsers and type robotcarwaikato.greatside.net, or another website is waikatorobotcar.greatside.net. We can open a website on internet and log in the website. Connect website MQTT brokers with this website, and ESP32 configuration, public and subscribe data to brokers, the same brokers with this website, so that we can operate a robot on internet. Actually, we can download the program for Android application on internet. I already upload to website, so just scan the QR code to download Android application and install for robot operations. Let's go fast from here. Okay, in the internet MQTT protocol operations, so we have one page for automatic control by path planning. But right now the communication between the sending data from internet to ESP32 is already done, but the control algorithm is not yet implemented. Okay, let's go another sections. Number 5. Control RobotCar by Android application MQTT protocol. I already make one Android application for controlling RobotCar interface like this. You can see, but the video is changing from the directions of the video.
Stop
so
robot
become
car.
very small, very hard to see.
Start robot car.
Yeah.
Move forward. Move backward.
There are many ways to control RobotCar by Python program on PCs with MQTT protocol, LoRa communication protocol, and by image recognition using YOLO 11. There are 3 ways to control by Python. So by MQTTs, let's start the RobotCar.
In front we have stove, LoRa communications. Open Python applications.
Okay, we open Python applications.
Coming forward.
Application, we already mentioned that there's many ways to control RobotCars. Actually, it's 9 ways to control RobotCars, not 6 ways.
Brokers, MQTT.
We set up MQTT brokers and click start.
Connect.
Now MQTT already connected. ESP32 connect to MQTT, and Python program also connect to MQTT. So also on data from ESP32 from RobotCar will change to Python programs.
I open for app cameras. You can see.
Okay, now we try to start robot by see on the Python program I already make one interface for control robot. So we just press the buttons and the car will change, will move. Okay, let's go to the next action. 6.2, control RobotCar by using LoRa communications. Because LoRa communication is uses in case there is no connection between remote and robot, because the distance is too far. LoRa is have long range communication, so that it can send and receive signal from the robot.
Control robot can call 17. Okay, like that. Okay. State this, and then you just open convert.
Okay,
See that
I already opened terminal convert to check the receiver.
Data from LoRa.
Receive data from robot.
Testing that are coming to LoRa or not. Close terminal from here.
I close this and open Python program. Okay. Right now we don't use MQTT protocol, but we use LoRa only. So we set up LoRa communication COM port.
COM7 and
Lead port.
Just click this port.
COM7 is used for LoRa. So set up COM7 for LoRa communications.
COM7 in click set. Now LoRa is already set to COM7.
And click start.
Start LoRa.
Start LoRa.
Right now is there no data coming to
After start LoRa, you can see the data already. We change the LoRa controls. On data from RobotCar we send to Python program. Now the data is sent from LoRa only. Data sent from ESP32 to Python program by LoRa.
LoRa here. Not from MQTTs. LoRa here. Sorry. This one is closed. Now I want to start robots by LoRa. Actually, starting robot by LoRa is not very easy, but let me try. Right. And enable that here. Okay. We need to start many times
because LoRa is not good
transfer and receive
with the speed control, like it's cannot transmit and receive at the same times. Normally when transmit and receive, it should have a time to transmit receive. So when the speed of data transmitted too much, and it's very hard to receive data.
Response of LoRa is not very good.
To make the LoRa communication
but send and receive
like to control car, we need to reduce the frequency of data transmit. Okay, we go to the next sections. Python, we control the robot car by Python image processing. Open Python applications.
Labeling view cam number 1. We do is set up robots.
Set up.
Start camera.
Set up the camera or control. We move fast. Okay, this is image in front of you. So when the camera is stay at this side, it will control motor moving forward. Forward.
When it sees the sign of this, the camera sometimes it's incorrect. Right first, turning left and turning right.
Turn left,
sometimes
turn right.
Turning left.
Okay.
Okay, right now we can control speed. Control depend on the data.
And change speed for motor. Okay, we finished the Python image processing. Go another sections. This is like idea only, but I have not finished the control program. What is automatic control by path planning (RPS).
Idea is to control car, make the program for this. Waikato RobotCarGridSite.net.
We open
And we
Waikato
enter this website
RobotCarGridSite.net.
Go to map
and
control.
we go to map controls.
It is a website for controlling robots.
In the map control,
you know,
set up
it is a map for path planning for robot operation.
Robot cars.
So in the map, we can set up the distance and the direct the
car will reach.
Path plannings for robot cars. Example, I need to set up 4 point. Car will moving from marker A to marker 4. Marker 8 and to number 2 and marker 3 and then go to marker 4 and coming back
with
marker
4 markers
so
car
position have the heading
and
each position we have the position here, heading and distance. Example like from marker 1 to marker 2, the distance is 81 meters and 75.45 degrees.
From website to ESP32.
Okay, at heading. Car position here. So what we do is now just set up the path planning for cars. Going down and yeah, we have a button set navigation plan. So when we set navigation plan, the data
set navigation
plan will send to ESP32 by MQTT connections. On this data we send to ESP32. Let me open the robot finals.
In Arduino IDE is program
I opened this
ESP32s. I already
data path planning will send to
read data from
the internet
website.
Data path planning is opened by website and sent by MQTT to ESP32 and it's make a plan for control car moving
to receive data and
to the direction that we already set.
Following the path planning.
Robot finals, when example like when we send the signal from website to robot, it will remember from here. Let's see from here. Yeah. When we send the signal from website,
the web space,
ESP32 will check
coming to this side.
if it's a signal from website for RPS path planning or not. And
so
if
here we can
yes,
extract data
if you
and send data to
extract data from
variable, robot
check
will
data
following the path
and
planning.
operate robot automatically. Yeah, from here in the data heading and GPS position and distance it will be set from here. Robot will move and operate automatically. The problem is I am facing is how to write the automatic program to control car. Idea is to
one of the most important things for ESP32 that how to update program without connect the hardware cable to ESP32. In these programs, robot controller ESP32 is programmed to update program over Wi-Fi without any physical connection to controller. So to update firmware ESP32 controllers, just follow the short video below. Update program for ESP32.
How to update firmware? You need to wait a minute. I open this side. Okay. We need to controller is so to update.
Okay, the first time we open Arduino IDE to change some things.
Open Arduino IDE program. This is project for robot.
And I need to, after changing some things, we export.
Let me start again. Open Arduino IDE program. This is project for robot. Main program, many main program from here. Global variable.
This is
We
main
have
program of ESP32.
every
Let's see
project
how to export data to
the file
binary
manager,
files.
global variable, temperature, humidity, robot goals, and remote. First time we RobotCar, if compare with original program Python RobotCar ESP32 here, Nicholas, the original program is very less, very simple.
Let me limit the
This is
strings of
original
this.
program. It's only one page, but our complicated because.
Okay, stand by. From here you see this is the main program of ESP32. We go to scat and export and compile binary files. After compile binary files, we go to the next
export
step.
Binaries. Okay. After export, you see that program will export to
compile
binary
scat.
files, and you come
We
inside.
convert the scat to binaries and go to main program.
Let me see. ESP32's robot.
ESP32 robot.
Yeah.
Learn and
RobotCar. Go to robot final program, and go to here in build folders ESP32, and this is the one
the first that
we need to
robot
upload
final
to ESP32.
dot binary. This is the
Waiting
one we need to
until
update to
complete.
ESP32.
Let me see. It's uploading, waiting. Okay, now already complicated comply to binaries. What you do is only type
We open
IP
website
address
for
of ESP32
direct on
and
ESP32.
go to main page.
Remember,
open
update only one ways. We only open website directly on ESP32.
Or you only just type
and
IP
click
address,
config views.
Config. Here.
Yeah.
And
Then
update firmware for ESP32.
choose the file want to update.
And choose file.
Yeah. Robot final binary, the first one.
Binary file from here. And then
click
update. After that, if you have connected this one, because
you can see that update process is successful.
And reboot
ESP32 reboot.
We can see the action
So
from
update
here.
confirm successful. Well done.
Update firmware successful. Now you are already complete firmware update.
Go another section.
How to update?
How to update or change web page for ESP32 or Raspberry Pis. Because ESP32 RobotCar controllers is using HTML JavaScript, so we need to update and changing something. We do following the video.
Hello, here not only the web page, robot final here. Okay.
Okay, web page of robot in
normally,
the data
you
folder.
Can change data, edit the program.
If you want to change something in the
here.
index files, and just change it and save it.
Normally, you can edit the web page from here, and then you upload it to ESP32. However, in some case, when you edit to ESP,
okay, you go to FF File Manager.
FS Flat is for
of the
manager the
ESP32.
file inside ESP32. So
open directories. We can see on the file in
of web page here.
File Manager.
So example, want to update index space.
If you want to upload index files.
Is this page. You want to change some tag or something here.
Yeah, index is the main page.
Is open file managers from here. If you don't have the file, what you do is just download this file. Example, you download this file, and you can just keep.
You can download the file from ESP32 to
index
computers.
File, example like this. Download index file. And then you do some change in the index file.
Go to download folder to check.
Refresh. If download folders, you see index here.
Okay, index files already download from.
Otherwise, you
from
already have
ESP32.
data inside the project. You just change something from here and then update the program. And now you want to update this, just click upload. Choose file.
Choose file want to update.
And the file you want to update is in robot file, no project in data. Example, you want to update index files.
Index.
Just choose
click
files
update.
and upload. And complete. Now
update
the
successful.
index file already upload. And check directories. In the file manager, you also can see the
now the
MQTT
web
setup
page
data.
in ESP32 already
Just
updated.
click here and
MQTT
download
setting
MQTT.
can check
And you can
in
read
here.
data setup of MQTT, MQTT server, and username, password, and topic, public, and supply here. Okay, the web page already complete. Update. Hello,
Okay,
how
let's
to
go
update
another
web?
Challenge and limitations. The limitation is if we stay very far from Wi-Fi, so the communication will affect to the controlling over website or mobile network, affect to real-time controls, and sensor accuracy like RPS or ultralitic sensors noise gonna impact to the robot performance. So sometimes we need to override the ultralitic sensor because ultralitic sensor is sometimes working unstable. It will stop robot unexpectedly. The robot car battery life, IoT component consume more power, require efficient energy management. It's more power, it's more heavy. Because more batteries, the weight of robot car increase. And the effect to the load. The environmental factors like sunlight interface, reflectance sensors, or road interface affect to the cameras when we use the camera. And one more important is like the weights of cars include batteries also affect to the power durations. Actually, one more, if we use image processing in control cars, is more to make the image processing reliable. We need to have more data sets with many angle of pictures to be trained. Future improvement and application. Enhanced program of automatic control following navigation plans by GPS. Improve dataset quality to control over traffic size. Or PID control for motor speed regulations. Or apply MQTT server, MySQL server to store data of robot cars. Actually, it's not very hard to improve this section. MySQL server implemented. So we can implement MySQL in Raspberry Pi web server. We can store data of robot cars. Conclusions. IoT technology allow real-time control monitoring robot cars. The combination of sensor, microcontrollers, and cloud connectivity, internet connectivities is enable very autonomous operations. And future improvements like in AIs or 5G data, it like transfer very fast, will make this system more powerful. IoT based on robots will save the future of automations. Thank you very much for your watching. So, any questions? Thank you. We finished the slide today.